It's an inequality. Not equal. It is not equal. So in other words, it is not this, right? Not an equal sign. An inequality would be one of these guys, right? We're going to be using inequalities in comparing parts of triangles. And so I have this theorem for you. It's called the triangle inequality theorem, and it says this. A triangle exists if the sum of the two smaller sides is larger than, any guesses? You can make a triangle if the sum of your two smaller sides of a triangle is larger than
the other sum.
The other, not the other sum, the other.
The other side.
Mm-hmm. Actually, we won't call it the other. We'll call it the third. It's to a triangle, yep. So in other words, you can make a triangle if when you take the smaller two sides of that triangle and add them together, if that sum is more than the third one by itself. Okay, and this is it's very logical. If you stop and think about it, if I were going to try to make a triangle, let's just say that this side of my triangle has a length of 5. If I took a side with a length of 2 and another side with a length of 2, if I move those down, will they ever meet? No, a 2 and a 2 are never going to meet, right? Here and here. This is 2, this is 2. You'd have one unit in between that does not make a triangle. So there's no way to make a triangle with sides of 2, 2, and 5. Okay? How about if I took a 5 and this side was a 2 and this side was a 3? Can you make a triangle?
Yes, it's equilateral.
Where do they touch?
They touch at each other.
They touch on the line. Does that make a triangle?
That's not good.
So this won't make a triangle either. But if I go, this is 5, and I go 3, ooh, that's interesting. 3 and 3, those will touch before they flatten, right? So as long as the two added together are more than the third, you get a triangle out of it, okay? So let's take a look at this. It says, determine if the following side lengths could form a triangle. Prove it with an inequality. Side note, you don't get to just tell me yes or no in your homework. I need to see some form of an inequality. I need to see either, so like on this one, what are your two smallest sides? Number 1. 8 and 17. So 8 plus 17 has to be bigger than 24. Is it?
Yes.
Who's out there? What does she want? All right, so 8 plus 17 is what? 25. Is 25 bigger than 24? Greater than 24? Yes. So would this make a triangle? The answer is yes. Okay, so here's what I need to see from you in your homework. If you're the type that's going to do it in your head, go for it. Give me 25 is greater than 24. If you're the type that's going to write it out and then plug it into your calculator, go for it. But I need to see one of those two. Doesn't have to be both of them, but I need to see one of both, or one of either. So that would be that setup. Look at number 2. Can you get a triangle with side lengths of 3, 3, and 7?
No.
Why not?
There's an equal space.
3 plus 3 is not
It's not 7.
greater than 7, right? 6 is not greater than 7. So this would be no. You cannot make a triangle with sides of 3, 3, and 7. So can you make a triangle with sides of 25, 35, and 12? Why? Which two sides do you need to add together?
12 and 25.
The two smallest. 12 plus 25 has to be greater than 35. So this is 37 is greater than 35. That checks out. So yes, you can make a triangle. Does that make sense? Very logical, right? Does number 5 make a triangle? No, because if you go 22 plus 28, that equals 50. 50 is not greater than 50. So equal does not work. Has to be more than for it to work. So this would be no. Okay. Okay, so what that means is if you have two sides of a triangle and you're trying to figure out what could the third side be, there's going to be a range for that, right? If I took 14 and 21, let's just pretend for a minute that my hand is 14 and my arm is 21. I know it's not logical, but pretend. So if my hand is 14 and this is 21, I could make a triangle where that third side is right here, right? But what happens if I change this angle up top? What happened to that third side? It got smaller, right? What happens if I make that angle bigger? That third side got bigger, okay? So there's going to be a range. It's not like this has to be the third side. There's a range of values that could work there. Here's how you figure it out. If given two sides of a triangle, you can set up an inequality using the sum and the difference to show the range of possible values for that third side, okay? And anything within that range will work then. So what we do, what's a sum? Addition. What's a difference? Subtraction. So if I go 22 minus 14, okay, I get, what's 22 minus 14, you guys? 8. I get 8 there. If I go 22 plus 14, I get 36, okay? Could I have gone 14 minus 22? Why not? You can't have a negative side length, okay? So sometimes people are like, how do you know which one to subtract from which? Subtract them so they're positive because you can't have negative side lengths, okay? What this is saying is 8 is the low end and 36 is the high end. So the range of values is between 8 and 36. Now question, does that include 8 and 36? Could you have a side length of 8? Could you have a side length of 36? Why? 14 plus 22, is that more than 36? No, it's equal to 36, right? So it's got to be something in between those two numbers. It does not include those two numbers, okay, between them. All right, look at, let's do 13. Figure out what that range of values should be if one of your sides is going to be 24 and one of them is going to be 7. Work that out. What's your range? Between what and what? 17 and 31. So if you subtract them, you get 17. And if you add them, you get 31. Okay? If you look over here, it says let x be the third side. You basically always want this set up where this is always your difference when you subtract them, and this is always the sum number. It does not make sense to say 31 is less than x, which is less than 17, right? Because now you're saying your side is either less than 17 or more than 31, and that will not work for any of them. So make sure that you're not doing that. You're always putting the smallest on the left side and the biggest on the right side.
Do you have to show the subtraction and addition part?
No, that's okay. You can just draw, as long as you write this out for me, I'm fine with that. Okay, so here's my question. If they give you these two sides, which of these will work? Check which ones will work. Put a little check mark or an X through the ones that will work for that set of numbers. That's not helpful when you go back and try to do it in the homework later. And you don't have notes to get version at it.
Which ones work?
This be greater than, not equal to. All right. What'd you check off? Did you mark 34? Yeah, good. You should mark 34. Did you mark 12? Who marked 12? Raise your hand. Who did not? You should not. Why not 12? 12 is one of your numbers, right? If you subtract these, you get the 12. So if you add them, you get, what is that, 42. So this is your range. It says x has to be greater than 12 or 12 has to be less than x, which means 12 doesn't work. Okay, it's got to be something more than 12. 29. Did 29 work? It does, right? Because that's between these two numbers. How about 18? How about 43? 43 does not. So it should be those three. Okay, so you're looking for what numbers fall between 12 and 42, but don't include 12 and 42. Okay? All right, moving right along. Flip to the next page there. This is probably my favorite part of the lesson. I like it. We're going to do two different things here. We're going to put angles in order, and we're going to put sides in order. And let me just warn you right now, they're so similar that a lot of times when I ask people on the test to put it's usually the other one, I think. Put sides in order. They put the angles in order for me. I'm going to know the angles order. I mean, I'm going to know the side order too. But the angles are going to be there for me. Don't tell me the thing that you're looking at and put that in order. You got to tell me about the thing you're not looking at and put that in order. I think that'll make more sense after we do it, but I'll explain in just a minute. So if we're going to put angles in order in a triangle, how this works is the smallest angle in a triangle will always be opposite or across from. So the smallest angle is always across from the shortest side, which makes sense, right? If we're doing my arm thing again, if this angle here is like 90 degrees right now, I get this pretty big side length for my third side if my elbows are my end points, right? But if I make that angle smaller, what happened to the side length? My elbows got closer together, right? So the side of the triangle got shorter. If I make that angle bigger, now my elbows are further apart, that side got bigger, okay? So smallest angle is across from shortest side. That means the largest angle is opposite the largest side. Okay, so take a look at this triangle here. Notice they gave us 3 side lengths. They're asking us to put the angles in order. So don't tell me BC is the shortest, AB is the next, and AC is the longest. I can see that. I want to know about the angles associated with them. So it's talking about the angle across from it. What angle is across from the 10-foot side? Across from it is the C. So 10 is linked to C, okay? What's across from the 7? The A, right? So that's what you're looking for, is the side relates to what angle, okay? So if we're going to put the angles in order, this one says least to greatest. Pay attention, because sometimes it goes greatest to least. Sometimes it goes least to greatest. I hate having to take points off just because you read something wrong, but that's how it goes. What is your smallest angle? Angle A. Across from the shortest side, which is the 7, is angle A. What's your next smallest angle? Angle C. And then your biggest one is across from the biggest side, which is 13. So that's angle B. Okay. So try these two for me. Number 17 says put them in order from least to greatest. Number 19 says put them in order from greatest to least. See if you can order those 2 triangles for me. All right. What'd you get for number 17? Sophia. Angle M, angle P, and angle N. Yes, you may. So the shortest side is across from the smallest angle. Okay, so M goes first, then P across from the 20, then N across from the 24.
I got the 19.
Oh, you won 19? Okay. What'd you get?
C, B, D.
Yes. Biggest side across from the biggest angle. So this one's going greatest to least. So C, and then B, and then D. Okay. Questions on that? Okay. The next chunk is not really harder, but there is one extra little step that comes into play on this one. But the idea is exactly the same, okay? This one you're putting sides in order instead of angles in order. So if we're putting sides in order, we need to know things about the angles. Look at this picture. What do you think we need to find first? Shay? Yeah, we got to find that third angle. So that's the really only difference that we're doing in this one. Here's how this one works. The smallest side is opposite or across from the smallest angle. Okay, and the largest side is opposite the largest angle. So same idea, just kind of the converse of it, if you will. So you're going to start by taking a look at your numbers, 42 and 103, and the measure of angle F should add up to 180. So you're going to go 180 minus 42 minus 103, and you get 35. Okay, once you have all three of your angles, now it's going to feel very similar. However, how do you name an angle? How did we name angles up here? One letter with the little angle symbol in front of it, right? How do you name a side? Not three. That could be an angle. The bar over top, how many letters? With 2 letters, okay? So if I'm asking you to put sides in order, make sure it's 2 letters. If I'm asking you to put angles in order, you're probably just using 1 letter, or you may use 3, but that's a little extra. Okay, so if this is my setup, what is my smallest angle currently? The 35, okay? What side is associated with the 35? DE, this side right here, right? The one across the way. So DE is going to be your shortest segment. What's your next shortest segment? DF, yeah. The 42 is across from DF. And then your longest segment, across from the 103 is going to be EF. Okay, so find the angle, and then the one across from it is what you're working with. Cece, what are you doing right now? Put it away. Okay, so try that for 21 and 24. Notice this one is least to greatest. This one is greatest to least. Find your missing angle measure and put them in order. Go. Who can tell me the measure of angle K on number 21? What'd you get for this guy up here? Yeah, 92. Okay, so that's your first move, right? You're going to go 180 minus 31 minus 57 is a 92-degree angle. So you have all three of your angles now. What was your shortest side? 31 is your shortest angle, or your smallest angle. KL, the side across from it. So KL is the shortest. What's your next shortest? JK.
Does it matter what order?
Like LK or KL? Mm-mm. You can do either one. And then your biggest one, so across from the K, would be JL. So this would be least to greatest. Okay, questions on that? Okay, what'd you get for this one? What was your biggest side? BE is the biggest. What's the measure of that angle? 46. So once you know that's 46, remember the little box means 90, okay? So across from the biggest angle is your greatest side. So you would say BE. What's your next biggest side? BD. And then DE. All right, across from the 46 and then across from the smallest angle, DE. Good there? Okay, last thing, and I've kind of been explaining this to you already in not as many terms. There's this thing called the hinge theorem, and think of it like with my hands, right? A hinge, how the angle changes affects how the side changes, right? We learned a bunch of triangle congruence theorems, which said if you have an SAS setup, the triangles are congruent. You're going to kind of have an SAS setup, but the A is not a congruent A. Okay, the sides are going to be congruent, but the angles are going to change, and that's going to impact how the third side of the triangle relates to the other third side of the triangle. So here's how it works. It says if two sides of a triangle are congruent to two sides of another triangle. So if AB is congruent to DE and AC is congruent to DF, okay? And then the included angle in the first triangle, so angle A here, is larger than that angle in the second triangle, then the sides across from them will also have that same relationship, okay? So basically we're saying if you have that SAS setup where it is the included angle that we're looking at, okay, the angle between the two sides that we know, that angle measure impacts which side is bigger across from it, okay? So basically we're saying if the measure of angle A is greater than the measure of angle D, then segment BC is going to be greater than segment EF. Okay, the side across from it is how it will relate. The converse of that is also true. So now if we say that BC is greater than EF, then that means the measure of angle A is bigger than the measure of angle D. Okay? In other words, if this is 12 and this is 10, then angle A is bigger than angle D because the sides across from them have a bigger one and a smaller one that correspond. Okay? Okay, so take a look at this. Number one here, it says compare KL, that's this guy, to PM. That's this guy. So look at what you have. You have a side that corresponds to a side that corresponds to a side. What are the included angles in those two triangles? 79 and the 74. So if those included angles are different sizes, then the sides across from them have the same relationship. So if the 79 is bigger than the 74, then that means KL is bigger. Oh, sorry. KL is bigger than PM. Okay, so I want you to see if you can figure out number 2 and number 5 and number 7, either on your own or chat it up with someone nearby you, and then we'll be done. Just a refresher, because I'm going to call on some names here. If your symbol went like this, that means greater than, right? If your symbol went like this, that means less than. Okay. Number 2, Brooklyn, did you put greater than or less than? You put this way? BC is bigger, so less than. You did this way? Yes, less than. Take a look at this one. We know this side is congruent, and we know these two sides are congruent, and this would be our included angles, right? So this is bigger, this is smaller, so that means that BC is going to be bigger than AD. So if AD comes first, then you're going to say AD is less than BC. Good there? Okay. Number 5. Rachel, what'd you put for number 5?
I put angle D as more than.
Angle D is greater than H. So take a look at what we've got. You have 25 and 25. You have 16 and 16. So the included angle is what we're referring to, right? We're looking for how that included angle is. And if this is bigger than the 33, then D is bigger than H. Okay? Number 7, who wants it? Anybody want number 7? Cece wants it. What'd you get?
RSQ is less than.
RSQ is less than. So RSQ is this angle, and then TQS is this angle. So you have a 17 that corresponds to a 17. You have a reflexive, there is related to a reflexive. So across from this and across from that, this side is bigger, which means that that second angle is bigger. So RSQ is less than TQS.